Today we're going to extend our knowledge of using nonlinear systems a little bit further by going a little backwards. Okay? Geometry is what we did last year, right? Okay? So let's use what we know about systems and let's go back and talk a little bit about geometry. And it's funny because some people think we're going to go forward to talk about geometry, right? Right? Mm-hmm. Okay, because we're going to guess when we're going to use geometry again. Pre-cal next year. Okay, all right. So problem number 1 says a rectangular enclosure has an area of 384 square feet, but its perimeter is only 80 feet. Now, there's a lot of this stuff that I don't know if you guys for sure need to do, but we're going to do it just to see what's going on. Fair enough? Okay? So let's look at fact number 1. Fact number 1, it says, list possible lengths x and y for rectangles with an area of 384. Well, if x is 10, what's y? 38.4? How do you know it's 38.4? Area is 384. Its length times width equals area, right? So if we know the area and we know this length, we divide area by the length to find the width, correct? So 384 divided by 12. If the length is 12, what's the width? Oh yeah, we could use our calculators. That would be okay.
Yeah.
So everyone's opening up their calculators right now. Okay. 32. All right, somebody else. If the length is x, if the length is 14, what's the width? That's what I was thinking, John.
Huh?
Oh dear Lord.
Oh no.
27.43. Okay. What if is that exact or do we round that? Round it. Okay. So if the length is 16, 24. If the length is 18,
21.17.
384 divided by 18.
21.1.
So 21 and 1/3. So we've been going with decimals, so we'll keep going with decimals. Okay. What about 20? 19. Is that exact or did you round?
No, it's exact.
Exact. Okay. What about what are the 2 other options we could put in here?
22.
So that would follow the pattern, right? 22.
Mm-hmm.
What is it? 17.45.
45.
And what do you want to put next?
24.
24. Okay. 16. Exactly?
Yes.
Oh. Okay. That's interesting. Look at fact number 2. List possible lengths and widths for rectangles with a perimeter of 80. How are we going to do that? If we know x is 10, how are we going to figure that out? How do you find perimeter? Out of all the sides. How many lengths are there in a rectangle? 2 lengths. So 80 minus 2 of these. So 20 is 60. How many lengths are there? 2. So 60 divided by 2? 30. What about 12? Somebody do 12, somebody do 14, 16, 18, and 20. Spread it out. Spread out the work.
Alright, so.
Double this number.
Okay.
Subtract it from 80.
28 is 12.
Whatever we get, divide it by 2. So if the length is 12, then the width is 28. Who's got 14? 26. Who's got 16? You did 20?
Wow.
Okay, what is it for 20?
It's 20.
Yes.
It's 20? Okay. I need 16 and 18 still.
24, 16,
24 for 16?
18, 22.
22. Now, my guess is that you didn't do any math on those last two. I hope you didn't. Did you look at the pattern in the table? Hopefully you saw the pattern. So, what two values do you want to add here? 22 and 24. And what should we add here? 18 and 16. Okay? What ordered pair appears to solve the system? What are we looking for? If we graphed it, we would be looking for the point of intersection. So we're looking for the same point in the table, right? Doesn't this one appear to solve the system? Okay. So 16 and 24. Is there another possibility? Yeah, look. 24 and 16. Well, does that make sense?
Would that be,
Yeah, you're just changing the length and the width.
or like,
Yeah.
So it would be like if it was this way or if it was this way, right? Okay. Graph the system or solve it algebraically to confirm. How would you choose to graph the system? Would you graph, how would you choose to solve it? Would you graph it or solve it algebraically?
Probably.
But either way, what do we need? The two equations, right? How do we get area? So x times y equals the area, which is 384. How do we get perimeter?
you add
2x plus 2y equals 80. So is this set up in a way that we could solve it?
No.
What should we do maybe?
Should we just get X more? Or put
So get y by itself?
Yeah.
Okay, so if we're going to get y by itself, I divide both sides by x, right? So this would be y equals 384 over x, right? If I'm going to get y by itself here, I'm going to subtract 2x from both sides, which would be 2y equals negative 2x plus 80. And then I have to divide by everything by 2. So I'd get y equals negative x plus 40. Or 40 minus x, either way. You okay with that? Now if I have these two equations both equal to y, I could either plug it straight into my calculator or set them equal to each other.
True.
Does that make sense? Which way would you choose? Calculator? Okay, I'll do it that way. After I turn my calculator on, that is. Whoops. Jiminy Christmas. Okay, I have a weird window on my calculator for some reason. Probably something I did last time, right?
Yeah, that's what I have. That really
Well, let me just do this. This will be easier. New document that's a graph. Okay, much better. Let me zoom in just real quick so you can see my calculator. Okay, so my first equation is going to be 384 over x, right? And then my second equation is going to be 40 minus x. It's broken. Okay, we know it's not, right? Menu, window, settings. So what x values do I need? Look at what I'm given. And use your brain for this. We're talking about a physical shape. So do we need anything negative? No. I'm going to start at negative 1 though so I can see my axis. Okay? How high do I need to go? 30? Okay. I don't know why you said that. We'll talk about it in a minute. I mean, I'm just kidding about that, but you know what I'm saying. What about y minimums? Do I need to go negative? Okay, so negative 1, so I can see the axis. How high do I need to go? for my y values.
30 would work too.
30 would work for this side,
So what does it
but over here,
40?
maybe 40. Okay? So why did we choose negative 1? So you can see the axis. Why did I choose 30?
Because it's just over.
My highest x value is 24, so I want to be able to see the ends, right? So again, I chose negative 1 so I could see the axis. Why did I choose 40? My highest one on either table was 38.4. I want to be able to see that. Okay? Can you see 2 points of intersection on this graph? Yes, so let's go find them. Menu, analyze, intersection. Put it on the left-hand side and the right-hand side. Oh my gosh. 1624. Oh, I suspected that. Menu, analyze, intersection, left-hand side.
24 and 16.
My calculator's thinking really hard today.
Mine was 2.
Mine is really bad right now.
24 and 16.
You can barely see it right there, but you can still see it, right? Control, close. I'll scoot it up a little bit. Any questions? Okay. So are they always going to have a table like that that you can just fill in? No.
Nope, that's not how it works. Oh, we don't do that.
We're gonna go to number 5. Why are we gonna go to number 5?
Because the rest of them work.
Because the first 2 are rectangles. We already did an example on rectangles. What's 5?
Triangle.
Triangle. The shorter leg of a right triangle measures 6 centimeters. The hypotenuse is only 3 centimeters longer than the other leg. So the very first thing we have to do is we have to decide on the equations. Okay? So if everything is labeled exactly as it is, which one's the hypotenuse? The y. Okay, first of all, it tells you, right, the hypotenuse y. But you know by looking at it which one's the hypotenuse, right? Okay? The hypotenuse is only 3 centimeters longer than the other leg. So longer than x, because we already know this length. So the hypotenuse is only 3 centimeters longer than the other leg. Does that make sense as one of our equations? The short leg of the right triangle measures 6 centimeters. I need another equation. Can I use that information? What should I do with it? We could. We could absolutely use Pythagorean theorem. What is it? What would you say? What should it say then? X squared
Equals
plus
6.
6 squared equals y squared. Perfect. Is that enough information to solve this system then? Yeah. Now, look what it tells you out here. This is a suggestion, and at the top of the page it says, in the problems that follow, set up a system of equations to relate the quantities in the problem, then solve. You may see hints as to one or more of these suggested methods. Why would they suggest substitution on this problem?
Oh, because you can, like, instead of y, you can put x squared plus.
Yeah, one of the equations is already solved for y. The way we set it up automatically was solved for y. So they're suggesting substitution rather than having to try to figure out how to graph this second one, right? Okay? So if we do like it suggests, which I guess you don't have to, because like on this one there's 2 suggestions. You could do either one, right? Either substitution or quadratic formula, right? Okay? So how would I do this if I was doing substitution? X squared plus, is it going to mess anybody up if I write 36?
Nope.
Okay, good, because 6 squared is 36. Equals x plus 3 squared. Now, I'm a little terrified right now that you guys are going to be doing something that I've been fussing at you all year about, and I'm afraid you're going to do it wrong. Okay, good. No, I'm okay then. X squared plus 36 equals x plus 3 times x plus 3. Right? We got to distribute here. You You don't have to make the sound, but you can if you want. Yes, sir.
Where'd you get the square from to put over there?
Right there.
Because y was squared.
Yeah, y was squared. Yeah. So x squared plus 36 equals x squared plus 3x plus 3x plus 9. So x squared plus 36 equals, excuse me, x squared plus 6x plus 9. Now, watch this magic. If it's a quadratic, right? So I want to get everything on one side. I want to get it equal to 0. Yeah, look at this. Minus x squared minus x squared. 0, 0. You are absolutely right. This is not a quadratic anymore.
No more.
So instead of getting everything on one side, what do I need to do?
You just need to get the x.
At this point, I need to subtract 9 from both sides, don't I?
Yeah.
What is 36 minus 9? 27 equals 6x. So when I divide both sides by 6, what do I get? What is 27 divided by 6? 4.5. So is that my answer? X equals 4.5? What do you mean one of them? Oh, okay. So I know this length, right? I need to find this length. So you would plug it into the first one?
Yeah.
Why the first one? Why not the second one?
Shorter.
Oh, it's easier. Okay. All right. So x plus 3 is going to be y. So my solution is going to be x equals 4.5, y equals 7.5. Would I write that as an ordered pair? I mean, I could, right? Because I could, it would be the point of intersection, right, if I graphed it. I didn't, though. I didn't graph it.
I want to do it.
Would it be wrong if I put it as an ordered pair? No, absolutely not. Okay, it would not be wrong. But this is also correct. Fair enough? Yes? Okay, please circle these problems. 3 and 4. Oh, sorry. 3 and 4. Let's see. Let's do 7. Let's do 8. Let's do 9. Oh, 9. Let's do 11. Okay? So that we're clear. 3 and 4. 7 and 8. 9 and 11. Okay? Any of the others that you do, of course, will be extra credit. Okay? But for sure get those done. Any questions?
No, man.